lecture of our iOS and Swift course. And today we are going to start with the short introduction. We are going to shortly tell you a bit about iOS, about Xcode, about the tools we are going to use. We're also going to tell a bit about ourselves, and maybe also we'll share a bit about yourself. And depending on how much time left, we will also start a bit with the Swift fundamentals. Yeah, and I'm handing over to Wolf.
Yes, maybe just to confirm, can you see the slide set?
Yeah.
Okay, that's good. Awesome. Thank you very much. Welcome also from my side. Pretty excited to do this lecture with all of you. Yeah, I guess we can dive right into. Yeah, welcome again, and I guess we can jump right into the introduction. Yeah, this will be a rather short slide set. Just so you're aware, we will just talk about organizational stuff, overview of what we will do, grading details. Like Irina mentioned already, we will give you a bit of an insight, very short, about who we are, and ask you to do the very same. Then we will dive quickly into the iOS history and, like also Irina mentioned already, stuff we will work with, so tooling. And then we will have a quick insight already into the first tool we will use, Swift Playgrounds. Okay, lectures, overview, actually, sorry. What we aim to do, we want to give you detailed insight into Swift and iOS. So we want you to learn the programming language Swift and also iOS related frameworks that are either written in Swift or in Objective-C. That depends then on how old they are, mostly. And we want to give you all the knowledge you need to actually build an iOS application yourself. For that matter, we also have a few exercises prepared. It's not too many, hopefully. And you will also get time during the lectures to work on those, so you can ask questions and so on. And we will also have a small project modeled a bit later on. And I already mentioned a few goals. We want you to be familiar with Xcode, be able to use the IDE properly, give you a knowledge of Swift and commonly used iOS frameworks, design patterns that are most used on the iOS platform, and most importantly for us as well, to help you to be able to find and apply your own answers, so to your own questions. Exactly. Well, what you need, I've already heard that all of you have macOS machines, but yeah, so please make sure that you, so there's no need to install Xcode now. If you have already, that's great. But until the next lecture on Friday, or actually the next lecture next week, it would be great if you could install it, download and install it, sorry. And the Playgrounds app would also be very good if you could also already download that until the next lecture, because we will do a bit of demoing with that. And if you want to follow that, it would be good if you could use that. It's a rather small application, so you should be able to download that rather fast. Okay, contents, very brief and short introduction in what we are going to talk to you about. Yeah, so first lecture, pretty obvious. We're going to do the introduction today. The next two blocks will probably be booked with Swift fundamentals, because we really want you to have a solid understanding of this, because it's the base for everything else we do. Then we will have a few blocks for UIKit. That's the framework that we build user interfaces with on the iOS platform. So that's also pretty important, and that's the thing you will most likely work with. Also, if you do internships or you want to follow this professionally, so you will most likely work with UIKit. Then we're going to talk a bit about testing and also Git, so versioning, a bit of networking, because that's also something you will most likely do. Data storage and databases in terms of core data. And then we have, as you can see, 2 blocks of to be defined. What does that mean? Well, that depends. Easy answer. No, it highly depends on how fast we are with the progress. As this is the first time that we do this lecture, we had a bit of a hard time to know how long it would actually take us to finish all the slide sets that we prepared. So in order to be able to really dive as deep as we wanted to do, we would rather extend, for example, one UIKit block a bit longer, so we have a bit of free time there. And if you have anything that pops up for you during the next few lectures, we are very open for your ideas and for your input. If you have anything that you really want to hear about and that we should dive into and prepare some stuff, we'd highly appreciate that, and we're open for suggestions here if you have anything that you want to know in more detail. Then we're already at the 12th block. This will be mainly project working time, so also here there's not too much need to work on this outside of the lecture because you will have some time. And yeah, also here we're available for questions. And yeah. Then there is another block about App Store submissions and tooling. Here we will talk about best practices, about how to actually submit an app to the App Store. How does the process work? How does App Store Connect work, the tool that you actually use to submit apps to the App Store and all of these things, and how can you make this easier with certain tools that we will then go into detail about. And the 14th block is just a very short one. I think it's only two hours. There we will have the short project presentations. Exactly. Yeah, to the grading, because we need to talk about it. So 60% of your grade will come from exercises. It's, as you most probably already know, Moodle submissions, as in nearly all the other courses, I would assume. You will have, so as you saw in the slide before, we always have like those bigger blocks, like for example, Swift Fundamentals or UIKit. And after all of those blocks, so not after every block, but after one slide set, if you want to call it that way, we will have one exercise. So it's not after every lecture, but after every block. So for example, we have a Swift exercise, we have a UIKit exercise, just so you actually can apply your gained knowledge. And what we then want to do is to have one of you, which we can choose randomly, to actually present the solution then in the class, so we can talk about your approaches and yeah, see how it went. One thing that I want to mention is that you can skip one exercise, so there's no need to have any reason or so. You can just say, okay, yeah, I didn't have time, or there was other things that were more important. Yeah, we know that there's already enough to do, so you can skip one exercise. And then about the project, doesn't need to be anything big. It's just about you actually working on something you would want to work on. So it can be any small use case app with a few screens. We have a few specific requirements that we want you to do. Those will be announced soon. And yeah, as always, we will then be able to answer your questions if you have any. But like, if you have an idea, or like, yeah, you can already start collecting ideas, let's say it like that. And you can also ask if this would be like an appropriate idea, or if this is like enough. Like I said, it doesn't need to be a huge project. It's just to see that you can really apply this in a real life scenario as well. Okay, Irina, quickly hand over to you.
Yeah, so my name is Irina. I'm from Ukraine, and back there I started as a software engineer Android. And same at Fantastic, I started 3 years ago as Android. And at some point later, with the support of my amazing colleagues, I transitioned into iOS position, and I'm enjoying it right now. Also, in my free time, I'm collaborating with Revenderly. It's a pretty popular blog for Android and iOS developers to learn some new technologies or concepts. So there are a lot of courses, a lot of books, a lot of different things, and I'm working on the books and tutorials there, and to occasionally also work as a tech editor. And I guess that's it.
Thanks, Irina. Now to me, I'm Ralph. By the way, something that I wanted to mention earlier already. I hope it's fine that we are on a first name basis. How do you feel about that? Is anybody very opposed against that? Because I would rather have it like same for everybody. Is that okay?
It's all right.
If anybody feels uncomfortable now stating that they don't feel comfortable, just shoot me a message in Teams. Yeah, otherwise I'd say first name is the way to go. Yeah, I'm Ralph. I'm at Fantastic for a little bit more than 4 years now. Senior software engineer on the iOS platform, working on the Adidas training app mostly, and I also have the luck to be in the same team as Irina, to work with her. Maybe to mention from my side, I also did the mobile computing bachelor degree already some years ago. And I'm currently doing my master's degree in the finishing lane, hopefully soon. Yeah, we've linked our contacts in there. They're also in the Moodle course. So, or right now, Teams is also a very good option for that. So just feel free to shoot us a message with any questions. Okay. Now enough talking from us. I know introductions are annoying, but still to get a bit of an overview about you, maybe you can all quickly introduce yourself. Did you have previous coding experience? So did you code before Hagenberg? Did you already work with Swift and iOS? Did you already try it out? How did you feel about it? And I know this question is a hard one, so just answer if you want to. Expectations from the course. Yeah, so you can keep it very short, but just for us to get to know you a bit better, we'd really like to hear you talk about yourselves a bit. Yeah, anybody can start. Feel free to. Thanks. Yeah, that's cool. Thanks. Who's next?
Well, I guess I'll just go on.
Thank you.
Well, I was in the HTL Leonding like 5-6 years ago. That's my coding experience. And then I started to work 5 years, but more on Oracle databases. So it was more SQL, PLSQL. And well, yeah, that's the experience. Swift iOS, not really. I did look a little bit into it because of the project we got to do, like the semester project. Yeah, expectation from the course, I guess to learn enough that I can manage the project.
That would be good, yeah. Awesome, thank you.
I can go next. So I was in the HTL Lead Tech in Linz. So I have some coding experiences. With Swift, I bought a book about our iOS programming, I think 4 months ago, but I just opened it twice. So I tried making some small applications, but yeah, they are not, I have not so much experience with Swift, and my expectations from the course is, yeah, I want to make some applications and of course have at least a little bit of fun. So.
Yeah, let's hope we can work with that. Yeah.
Okay,
Thank
so
you.
I will go next. I have absolutely no experience with any coding, but I have to make the project in the other course with iOS. So I hope I can get as much as I need for that project in this course.
We'll try to do our best. Is this the semester project, like project development or something like that? Okay, cool.
So then I guess I'll be next. I'm also new in the coding segment, so I have no experience of any coding. And for me, it's also my expectations to learn enough to finish the project that we have and have to do. Mm-hmm. And so I have to do the iOS application. So I hope it would be we will learn enough to do this.
Surely hope so. Yes, we have a bit planned.
I think so. It would be work. I think so.
Cool. Thank you.
So I will go next. I also didn't have any coding experience before Hagenberg, and yes, I'm in the same team as Manuel, so I hope I can manage to make a decent app after the course in the project, and yeah.
Sounds good.
I go next. I have a coding experience before Hagenberg in Android Studio, also in Android, but not in Swift or iOS.
Did you write Kotlin or Java?
Java.
Okay. Cool. Yeah. Thanks.
I'll go next. So my name is Abdul. That's a short name for my really long name. Prior to Hagenberg, I attended HTL Mödling. There we worked with C#, C++, JavaScript, and PHP. And I have some experience with Swift, but not really iOS. It's not really common to work with Swift server-side, but I did a little bit server-side Swift. And I looked into Swift Kit, but Swift UI, but not really UI Kit. And I expect to be able to work with UI Kit after the course.
Yeah, sounds good. Thank you.
I will go next. My name is Simon, and I have absolutely no coding experience. And I'm in the same team as Manuel and Sebastian, and I'm looking forward to learn everything that I need to code the app we must do. Yeah.
Sounds good, yeah. Thank you.
I'll go next. I went to the HTL in Steyr. I have a lot of programming experience. I actually applied to Rantastic this year for a position as programmer, but while they were happy with my code. I'm unexperienced in Kotlin. And yeah, they didn't want a Java programmer. Yeah, I just expect to have fun at this course. That's about it.
Let's see what we can do about that. Thank you. Okay. Did somebody not say anything? I think so. Somebody has. Sorry, Florian. I think you just unmuted yourself. Or did you not?
I think he's too shy.
He has the mic enabled, but we don't hear anything. So I'm not sure if it's that or.
He wrote something.
He wrote something. Good. Thank you. Didn't see that. No, we cannot. Those are the difficulties of remote setup. But I guess everybody else did already introduce themselves. Yeah, sure. Let's wait a few seconds.
Well, sorry, can you hear me now?
Yes, that works.
Well, I changed to my phone. It somehow doesn't like the microphone.
That's okay.
I've had a bit of Java experience and Python experience prior to Hagenberg, but nothing with Swift or iOS.
Okay. Cool. Yeah. Thank you, Florian. That marks everybody. If my list keeping skills are correct, did somebody not introduce themselves? And I hope I did not miss anybody. In this case, silence means agreement. Then we can continue. Now to follow this introduction part, what we want to do next is to talk a bit about why iOS, how did iOS or iPhone OS develop itself over the years, or how Apple did or how Apple developed it over the years, and yeah, talk a bit about the tooling and what we might need during this course. Okay, let's dive into it. First question, why iOS? And this might be a bit biased from my side because I never did any real Android programming other than some side projects. So Xcode is, if it's not a bit buggy, a great development environment. So most of the time it works surprisingly well, especially for smaller projects. It's an amazing development environment. If you have a few thousand classes and like 100,000 lines of code or multiple tens of thousands lines of code, it gets a bit chunky and slow, but most of the time it's really cool. The framework support from Apple, there are frameworks for nearly everything, and that's pretty amazing. Also through third-party support, but that's also the case for Android. Beautiful applications. Due to the review process that Apple implemented, like already since the beginning of the iPhone and ecosystem, there were guidelines and standards that Apple apps, or that apps that are distributed on Apple systems, need to fulfill. And that's pretty amazing, because this sets a high bar for apps that they need to fulfill a certain standard and need to look a certain way. I remember trying to submit an app that I did like 6 or 7 years ago, and they just said, no, it doesn't look well enough. Check the human interface guidelines again. We will talk about those as well a bit later. But it just shows that they really try to keep a high standard, and yeah, you can see that in the App Store most of the times. And of course, the programming language also might be a bit biased, but Swift is really awesome, and it's very safe, and you can do all kinds of things with it. But Irina will tell us a bit more about that later. The ecosystem. With Swift, you can develop for iOS, iPadOS, the watch, the TV, and even macOS. Especially since the dawn of Swift UI, this makes it even easier to build cross-platform applications, and this is really amazing because it saves you a lot of work. This doesn't mean that you build it once and you use it everywhere the same, but it just makes the whole process more straightforward. And as I already mentioned, the apps, they go through a review process by Apple and therefore need to keep a certain standard, and Apple also checks if you do anything malicious in there. And the distribution only happens via the App Store or TestFlight. Just for those who don't know TestFlight, which is probably the case, TestFlight is an app pretty much that you can download from the App Store. And for example, we at Runtastic use it internally to provide builds to our testers. So you can define groups in a company, and certain groups then get certain builds. And this makes it way easier to know where the builds go, and you just makes it easier to distribute builds. There are certain exceptions. Sorry, there are certain exceptions though. For example, enterprise apps. What is an enterprise app? Internal apps. For example, it's just a random example now. We build an app that is only internally used at Runtastic to time track. For example, this could be distributed as an enterprise app. They work a bit differently. They are not on the App Store, but you can still distribute them. But those are only like for very specific use cases, and we will not cover those. Okay, after that, let's have a short dive into the history of the iOS platform. You all probably know that the iPhone was released sometime before, I think it was 2008. And with iPhone OS 2.0, this was released in March 2008, there were only web apps. In this case, a web app is more of a website that you open on your phone, because there were no non-native apps. It was really just apps that Apple provided and the web. That was it. With iPhone OS 3 in 2009, there were a few additions like copy-paste. Yes, the first iPhone OS version did not have copy-paste. A landscape keyboard, MMS, whoever uses those anymore. Accessoires, the map API actually went into that version. This was the first time that everybody's beloved push notifications came into play. So app developers can spam you with notifications. and also in-app purchases. This is very important because that's how you make money if you develop apps, if you don't charge for the app download. Okay, with iPhone OS 3.2, the support for iPads came, and build it once, ship it on multiple devices. So also this for the iPad. There were multiple adaptations then also with iOS 4, including a renaming from iPhone OS in 2010. And this was the first time it had real multitasking. So what do I mean by that? It allowed background usage. So the app can request runtime in the background to actually do stuff, do a network request, write some stuff in the database, whatever. The app could request that. And full background support for example, when audio plays. And with iOS 4.0, also the iPhone 4 came out, I think, if I'm not mistaken. And this was the first iPhone with a Retina display, so also iOS needed Retina assets. This means that we will talk about this in the UI kit slides a bit more, but different screen resolutions need different kind of assets. Yes. Then iOS 5.0. Introduction of automatic reference counting, so memory management. Before that, it was actually manual reference counting. Correct me if I'm wrong, but I think in C you still need to allocate and deallocate manually. So this was the case back there as well. Also, there was no Swift, so everything was in Objective-C. Yeah, so Arc, we will talk about this a bit later as well, is really very helpful and makes our lives way easier. And iOS 5 also introduced storyboards, which we will cover in quite some detail in the UI kit slides, because this is the way this is one way actually you can build user interfaces on the iOS platform. Okay, with iOS 6, it sounds boring, but there was really not that much new, at least nothing very exciting. There was this hugely promoted switch from Google Maps to Apple Maps, which failed dramatically because nothing worked. Yeah, so everybody uses Google Maps on their iPhone, or a lot of people at least. With iOS 7, there's a screenshot on the right where you can see how, so the right one is how it looked before. And with iOS 7, there was like this total redesign. Also, there was 64-bit support was introduced and a new architecture for those devices. And also SpriteKit, which is a framework for graphics and animations, which is mainly used in games. So yeah. With iOS 8, Swift was introduced, so yay. Also app extensions, for example, sharing or third-party keyboards actually. So I don't know if you're using a Google keyboard. This is available since iOS 8 or a bit later, probably. Also Touch ID, which is also accessible to apps via a framework. Also like then later with Face ID. Also Health and HomeKit, which we will not cover in this course. With iOS 9, Apple introduced the concept of 3D touch. I don't know if anybody remembers that because it's already outdated again. So they removed this. Also multitasking, so a split view on the iPad, having two apps next to each other, and the so-called app thinning technique. Maybe a short explanation on that. When you build an app and you ship it to Apple, it actually, the binary that you ship, so that the app file contains the architectures for all devices your app supports. So for example, the iPad, an older iPhone, a newer iPhone, and this bloats the binary size. So your app is actually bigger than it needs to be. And with app thinning, Apple actually strips unneeded architectures from your application. So the actual download size for your app on the App Store is smaller, which is pretty cool because you want your app to be as small as possible in order so that everybody can download it also in the mobile network, because there's a limitation. I think by now it's 200 megabytes, but a few years ago it was like 100, and this is rather small already. Yes, iOS 10, rich notifications, so you can adapt your notifications to look a bit different. In this case, push notifications. Siri support for developers, so Apple introduced an API, so if there are certain commands the user states, that, for example, your app would respond. And also widgets V1. Why V1? We will come to that, I think, in 2 slides. Those widgets are already legacy again, so they're not, I think you can still build them, but they're not like that great anymore. Let's call it like that. Yeah, with iOS 11, we're already getting closer to recent years. You would have a notification center on the lock screen, and UI UX improvements for the iPad. iOS 12 sounds like a rather boring release, but actually it was pretty cool because it focused heavily on performance, and this was really noticeable. And it also gave app developers a year of rather easy app migration, because new iOS release is always a time of great uncertainty because you never know what might hit you. With iOS 13, SwiftUI and Combine were introduced, so that's pretty cool. SwiftUI is a new UI framework, and Combine is actually a reactive programming framework, also all native by Apple. And with iOS 13, you can then actually use Catalyst, which brings iOS apps on the Mac. In this case, explicitly the Intel Macs, because M1 Macs anyways can run iOS apps. Yes. And iOS 14, released last year. With this, we had redesigned widgets, so widgets V2, which are SwiftUI only, and they're pretty cool. In the same release, they actually announced SwiftUI 2.0. They didn't name it that way, but there were a lot of great improvements to the way SwiftUI worked already. And yeah, I'm already excited what will happen this year. And app clips. So I'm not sure if you saw that because it's not that heavily in use. I think developers can provide very, very small parts of their app experience in, I think, maximum 10 megabyte downloads. So that, for example, if a user scans a barcode on a scooter, this, I don't know, some random scooter app will pop up and you can actually start your drive right there without downloading the app first. So it just improves the user experience. And you might have read this because there's a lot of drama from Facebook coming about this privacy improvements. So there's this unique identifier that identifies all of your phones, or at least the ones that have iPhones. There something similar exists on Android phones as well. The IDFA. So this is an identifier for advertising, and I want to keep this short now, but it's interesting, I think, to know how this works. This actually identifies you across apps. So if you, I don't know, look at something on your, I don't know, let's say you want to order food and you look at burgers and then you open Facebook and you get an ad for a burger. This is how Facebook knows to advertise you with a burger, because they share the identifier. And yeah, that's how Facebook knows. And with these privacy improvements in iOS 14 that are enforced with iOS 14.5, people can say they don't want to make this identifier available anymore. And yeah, there's some drama with Facebook and Apple. You can Google if you're more interested, but it's quite interesting what drama this caused, because this goes directly against Facebook's business model, or at least a big part of it. Yes, that was the platform history overview. And now about the iOS platform. On the right, you can see the different layers of the platform. So it starts, the top layer is the application layer. It says AppKit there, but UIKit also counts into this. So AppKit is the UI kit of macOS. So this provides the user interface. It's called Cocoa Touch in general. Below that, you have the media. This handles, for example, videos, audio, multiple other things that you might want to use. But I think videos and audio are the most prominent ones. Also, animations are lying in there. Core services, you will also probably get in touch with. We will definitely get in touch with it in the course. Core data, for example, is a database framework, kind of a wrapper around some storage that you can choose on your own. But we will get in that also in a different slide set. What else? Yeah, WebKit, for example, so letting the user access websites from your application. And CoreOS, yeah, you will probably not get in touch with that. We will also not cover anything of that in the course, and also not from the kernel. We will not get that deep into it. Well, networking, yes, but we will use the high-level APIs to do that. Yeah, to the components. Yeah, so what will we use to develop? Xcode in its latest version, 12.5 or 12.4, depending on the macOS version you're on, is also fine. So one of the latest versions would be good. Instruments is a pretty cool thing. We will have a quick look into that when we introduce Xcode, because this allows you a very detailed performance analysis. So if you ever have an app that in some cases just locks up and stops acting properly, you can use instruments to find the root cause and fix it. Which languages are used on the iOS platform? Obviously, Swift what we will heavily cover, but also Objective-C is still around, and it's probably not going anywhere that fast. A lot of older code, especially in bigger companies or companies that have apps in the App Store for quite some time, the chance is high that you will see some Objective-C code. For example, we started heavily writing Swift when it came out, but we still have quite some code in Objective-C, which is okay because it works fine and it's still a valid approach. Yeah, as I mentioned, frameworks, so Foundation, UIKit, AV Foundation, for example, for videos and audio. Yeah, there are lots and lots of those. And architectural design patterns, we will focus on MVC. We might have a look into MVVM depending on how fast we progress. And there's also other design patterns that are very heavily used by the system itself, for example, delegation, which is heavily relied on. But we will get to that in the UIKit slides. And I think with that, we earned a break. I talked a lot now. What do we say, Irina? 10 minutes?
Yeah, let's do it. And then I will continue with the playgrounds.
Yeah, so 36, fine for everybody?
Sure.
Yep.
Yeah.
Okay, then see you then.
A question.
Sure.
Can you please put the slides to the Moodle?
Yes, I'm sorry,
Is
I
it
didn't
possible?
enable them. Yeah, sure, they're on there, but they're hidden.
Okay.
I'm sorry, I forgot. Thanks
Thank
for the
you.
hint. See you in 10 minutes.
See you.
So, welcome back, everybody. Yeah, as we already said, I'll hand over to Irina now to talk you through the first tool that we're going to use, or the first development environment, actually, Swift Playgrounds.
Yeah, so I will start sharing my screen. Just a second. And please let me know if you can see it.
Yes, works.
Yep.
Perfect. So yeah, now we will start with the playgrounds. As Ralph mentioned, it's an interactive development environment, a built-in feature of Xcode. Basically, it lets you play around a bit with Swift programming, and you can see the result of the execution of your code in real time. Playgrounds is a special Xcode file which can be created either in Xcode directly or in a standalone application, which is available for both macOS and iPadOS. So you can just download it even on your iPad. Yeah, it's really a convenient tool to just try out a block of code to see whether it works. And we are going to use Playgrounds for practicing Swift up until we start with the UI kit and a bit bigger applications. Yeah, so when you create a playground in Xcode, in the menu like that, you will be offered to pick one of the 4 templates. First one is blank, so you will just get an empty playground file where you can put your code and run it. If you pick the game template, the Xcode will generate some boilerplate code for you to try out SpriteKit. So yeah, you can build some graphics stuff, but most commonly it's used for games. If you pick map, it will import MapKit for you, so you can build some map views. And if you pick single view, Xcode will generate a view controller for you, so that you can build some basic user interface using UIKit. Yeah. The Playgrounds app, the standalone one, is really similar, but there are a few differences. First, there are a lot of hints and things which kind of help you to see what's going on, to understand the code. And also there are a few pre-existing templates which can teach you some concepts, programming concepts in a playful way, kind of with pictures and animations and stuff like that. Yeah, so as I mentioned, the functionality is rather similar, but it's a bit more interactive, so you can not only run your code, but go step by step to see what exactly happens in which order. And here we put a few links which may be useful for you, where you can get to know more about Swift and iOS in general. So if you have time, just look into it. There are really a lot of nice resources. Especially Hacking with Swift is an amazing resource. Like any problem which you Google, usually they have just an article on how to build a workaround or solve it. And yeah, we can start with Swift fundamentals. Yeah, but if you have any questions now, you could also ask them now before we start with Swift. If there are no questions, I will start with Swift. Just a second.
One thing that maybe to mention for Playgrounds, I'm sure you will get into that as well. It's top to bottom, so it really matters if you define a method below the point where you call it, because then it will not work. But you can show that in the playground then.
Yeah. So yeah, actually I can just show you a bit. Here's the playground. You still can see my Xcode, right?
Yes, but maybe zoom in a bit. That would be cool.
I have another question.
Yeah.
Is there something like C prototyping where you can define the function below and give it a declaration that there is a function?
No, that
prototyping in C and C++.
no, you don't do it like that in Swift. But actually, as far I'm aware, and we will try it out right now. Once Playgrounds app actually compiles the whole file, then it actually sees the functions below, so it will work. But if you just type it immediately in this order, it may not see it, and you will see an error. So just if you're playing around with some code, it makes sense to keep the order so that you don't get confused with some errors. Yeah, but we will see right now. Yeah, this is the Xcode version of Playground, and here the standalone app, which you can download from App Store separately. As you see, there are some template playgrounds, learn to code, and yeah, basically in a playful way you can learn some concept. But what you would mostly use if you decide to use the Playgrounds app, it's a blank one. Yeah, like this. As you see, there are a lot of hints, some control flow and stuff like that. Let's say I want to say print something. And I want to see the console. Just a second. My setup here is not really convenient. I don't see the corner. Yeah, here you can see the console. So the output of your application. Normally, you don't use it when you program an actual app, because obviously you cannot see the console. There is login, which you can use for you to understand what's going on in your app, but normally you wouldn't use print. You use it just for trying out stuff and see whether it works. Yeah, and for example, if you have more lines of code, let's print again something, and maybe even in the loop. Whatever. And if you run the code step by step, yeah, it's really not convenient. I'm sorry. Run my code. Okay. I just wanted to show you how it executes it step by step.
I think the endless loop breaks it.
Okay, I just thought I can stop it myself. Okay, I broke it.
Yeah, such things can happen with the Playground.
Yeah, sorry. I will stop it now.
Always be careful with endless loops.
Yeah, I thought I can just interrupt it myself. But yeah, okay, all good. Let's go back to the Xcode version of it, I guess. Yeah, as I said, when you have multiple lines of code, let's print something again. And like that. In the playgrounds, you can pick what exactly you want to execute. So let's say if I press here, I should see only one line printed. If I press here, all of them should be executed. Yeah, like this. In the playground, you can also have more files and more resources, but it's not really common, because if you want to build something bigger, you already built a proper application, and just to try out some stuff, some algorithm or something like that, it's enough to have just one file. Yeah, and I think now we can start with Swift.
I just uploaded those slides to the e-learning as well, so you can also download them from there if you want.
Thank you. Yeah, so let's start with the variables and constants. First, when you create a variable, in Swift, you can easily control the mutability of this variable. If you use var keyword, so here you declare age variable using var keyword and assign it a value. And in this case, you can actually modify it later as many times as you want because you declared it that it's mutable. Yeah. If you declare a variable using let keyword, you let your compiler know that you are not, you don't intend to modify it anytime later. And in this case, later on, if you by mistake assign a new value to it, the compiler will let you know that you're doing something wrong. And actually, it's preferred to use immutable variables as much as possible, unless, of course, it's necessary to change some value, because it makes your code more predictable. So imagine you have a really huge class with insane amount of functionality, and somebody else needs to review it. So somebody who didn't write this class. And when you're reading it, you need to kind of grasp the idea and understand what's going on. And it obviously can be really hard, but at least when you see that some variable is constant, you know that, okay, this thing is not going to change, and in any place where I see this variable, I know what value exactly it has. So it at least simplifies something for you. Yeah, and of course the code less error prone. And another thing to note that the mutability control works differently depending on the semantic of the type you use. I will talk about that literally in 2 slides, I think. But in this case, we used int and string type for these variables. So to represent a number and a set of characters. This is value type in Swift, and basically when you declare it as constant, you cannot really change it in any way. But later I will tell you about reference types, and you will see that it can be just a bit more tricky. But first, let's find out what type is. Anytime you declare any variable to keep some data, it always has some type. So compiler always needs to know what exactly you want to store in this variable, and there cannot be any uncertainty. You cannot say, here is a variable, and later I will tell what type it is. Compiler needs to know immediately. So the type can be, for example, int or double. So the ones which come from Swift standard library, they're already created for you. You don't need to do it yourself. And they can be also created by yourself or by other engineers. It can be user, workout, exercise, anything. So any data representation which you need for your app. For example, if you have a to-do list app, you would have a task and you would have a list and something like that. Swift is a type-safe, statically typed programming language. It means that first, as I mentioned, compiler needs to know about all the types immediately. And if you assign, for example, you have a variable of int type, and later you try to assign the wrong type to it, compiler will let you know. You will get a compile time error. And yeah, this is actually really good because you, as an engineer, you will see the compile time error. And it's really good because it's not a user, because runtime errors are worse, because yeah, you cannot always see them before you ship your app. And Swift compiler is also really smart, and it can understand the type of the variable in many situations without you actually telling what type this variable has. So let's look at this example. We define a variable age, and then immediately assign to it int literal. So literal is a value, which is equal, for the compiler, it's equal as you would say var age int. Here we define the type explicitly, equals 25. So from this line, compiler understands that variable age will have type int, and it's not going to change. So if you later on by mistake assign a string representation of this number or whatever, user or something else, you will get again a compile time error. And now, value and reference semantics. All types in Swift fall into one of these categories. Depending on the category, the behavior of the variable of this type can change rather significantly. And let's look how exactly it works. So, for example, you have a variable of type dog, and if it's a value semantic, if it's a value category, your variable contains the instance of the dog itself. So it's like, this is the variable and that's what it contains inside. And multiple variables, they cannot share the same instance. So they can be copied over. So you can have kind of the same dog with the same properties, but it won't be exactly the same dog, but rather a copy of it. And if we're talking about reference types, it works a bit differently. You have a variable, and it doesn't contain instance itself. It just contains a reference to this instance, which means that multiple variables can reference the same instance. And it also means that if you make any change to the instance through this variable, this one will also be affected because they literally point to the same instance. And yeah, that's why I mentioned that the mutability control would be different depending on the type. So when you define a variable of value type and say that it's let, so constant, you cannot change anything about it. But if you define a reference type variable as let, you cannot change this reference anymore because it's a constant. But the instance to which this variable points to can be changed as much as you want. You can rename your dog, you can put another leg or something like that. In Swift, tuples, structs, and enums have value semantic, and classes, functions, and closures have reference semantic. You don't need to remember it right now, really. We're going to look in detail on each type, and then you will see how each of these type really behaves. Don't need to remember or learn it by heart right now. Yeah, and let's look into a small example. Here we have a user model implemented using both approaches, so struct and class. This is value semantic, this is reference semantic. They have the same properties, really no difference except for the structs. You don't need to define the initializer. We'll come back to initializers later, but that's just so you understand they actually do the same thing pretty much. Oh, sorry. Yeah. And if we define a variable of this type, of struct type, as a constant, as you see, when we try to change any property of it, so we created a user struct, new user struct with name John and age 32, and then we say user struct.age and set a new value to it, compiler won't let us do it because this variable defined as a constant, and since it has value semantic, you cannot really update it. But then if we declare another variable and declare it as a mutable variable and assign the value of the immutable variable, we actually can modify it. But here, be really careful. Since it's value semantic, this line is essentially equal to you assigning a new instance of the struct to this variable. So you just created another copy, another instance, and they don't share any instances. These two variables do not share any instance between themselves. So here you said that user struct 2.h equals 34, but it doesn't mean that the property of this variable changed. So it's still going to be 32. It wasn't changed here and it wasn't changed here. So every time you assign a value type variable value to another value, you just copy it over, but they don't share these instances, which is really different for classes. Basically here we did exactly the same thing as here. We create an instance of user class, Jim age 29, and then although it is declared as let, so constant, we still can update age. So obviously, I mean, not obviously, but if you declare it as let, you cannot assign a new instance anymore because it is constant. You cannot change reference, but you still can change the properties of the instance which this variable points to. And we create another variable and assign the value of the first one to it. And then we change the age, and actually both variables are affected because they share the instance. And if you modify any property through any of the variables, it will be updated for all of them. Yeah. And now I will just switch to the playground. I pretty much want to do the same thing, just step by step, so it's more clear what exactly is going on. Yeah, let's do it here. So let's start with this struct. For example, student. Let's say student has a name and student has faculty. Then we declare a variable, student John. We create a new instance of the struct. Yeah, so that's how it works. That's how you create a new instance in Swift. In many other programming languages as well. You put a name of the type, and then you invoke the constructor or initializer of this type. But yeah, we will look into it in more detail later. Let's name him John, and let's say he's studying mathematics. As you see, I declared the variable is let, so I actually cannot do anything anymore with it. Yeah, the compiler says that I cannot update its value. And it will work if I declare it mutable. And again, if I declare it immutable here in the struct itself, it won't work again. So any variable can declare its immutability using let keyword. And once again, let's declare immutable variable. Student hidden John. And let's change the name, because we can do that since the this variable is declared with var. And now let's see what happens. So in the playgrounds, you can run it like this. And then let's this. And you see what happens. These variables are actually different. They have different instances. As you see, the name is different, which means since the struct has value semantics, the instance was just copied and not shared. If we, for example, declare this class, we need to have initializer. I will real quick put it here. Okay. Here we need to assign the values of the parameters of the initializer to the properties of the class. So how we're doing it, since the names of the properties are actually equal to the parameters of the initializer, we need to use self keyword, which is pretty much a reference to the instance of the type which you're inside of. But yeah, also more details on that later. What you're basically telling your compiler is that the name property of self, so of student, it should be assigned the value of the parameter of the initializer. And if you, as you can see, when you press on the variable, you can see where it's used, and you can see that we are doing exactly correct thing. If you press here, you see that it's a property. If you press here, you see that it's a parameter. So here it should work as well, all the same. But if we run it now, as you see, the values are exactly the same, so they actually share the instance. We can also check it this way. Student copy. Right. Let's see what it does. Yeah, it says true. So when you use 3 equals sign, you check not that it's just equal, but rather you check the reference, whether the reference is the same. So as you see, it says true. So the instance wasn't copied, but the reference was copied, and they share the exact same instance of the class student. Yeah. Now let's go a bit further. As I mentioned, tuple is an example of a value semantic type. It's a really convenient way to group a few elements together into one structure. It's literally just a list, a comma-separated list of these types. How you can use it, as you see, we define a variable again, and that's how we define a tuple. So there is no name for it. We don't say student or user or whatever. We just open the round brackets and put a list of the properties with comma one by one. You can also name them. So you say that this tuple, so this instance of the tuple will have x and y with 5 and 10 as values. And then since we declared this var, we can update value of x and set it to 15. So as you see, you declared the name of this property here, and the compiler already knows that this variable will have x and y as properties. And later on, you can access them this way. But again, since it's value type, here you pretty much assign a new instance of this tuple. So it's the same as you would say point.x equals round brackets x is 15 and y is 10. Yeah, as you see, the value is updated. Tuples can also be used as return type. You can just declare a function which returns a tuple. Here you can actually, not can, but should. Here you actually need to define the type of your elements of your tuple. Then, yeah, as soon as you declare the names of the parameters of the elements of your tuple, you cannot use any other names. The compiler is already aware of the correct names, and you cannot use any others, although you can omit them. So you can just say point equals 10, 20. Yeah, and when you define your tuple, if you omit the names, then they will be generated automatically. It will be just an index of the element in the tuple. So if you would say just var point equals 510, then it would, here you would say point.0 equals 15. So you access the first one, the first element of the tuple. The index starts from 0. Yeah. And also you can define a type alias, kind of alternative name for your tuple, because here, because of the name of the variable, you can kind of understand that it is a point. But if there are, for example, more components for readability, you can introduce a type alias. So here you said that it will be called vector4, and later on below you can use this type just as if it was class or struct or whatever. So you would just say var point equals vector4, and in the initializer you would put the values for your tuple. I can just show it real quick somewhere. So let's say we have type alias again student. Yeah, and then we can create a variable. Or I'm doing some, no. I just don't like that there is no auto completion weird. Let's see. Yeah, all good. As you see, we created an instance of this tuple. But usually you wouldn't really do it like that. If it's really a structure which you're going to use throughout your app, you would rather than have a struct. Type it, tuple is for rather something small and what is really in the scope of one class, just, yeah. And yeah, maybe I remember that a few of you are familiar with Java, so probably you know the void type. Basically, type void is a representation of empty. So it's not really nothing, because nothing is a different concept, but it's just empty. And in Swift, void is implemented as a type alias for empty tuple. So like this. Here you implemented void. Yeah. And now another important concept in Swift, like in many other languages, your variable can actually not have a value for now. So imagine you get some user information from the server. So you have a model for that user. And while you're waiting for the response from the server, you actually don't have anything. Obviously, you already have a variable, but the server is still taking time to respond. Even if it's a few milliseconds, it's still kind of, it's still asynchronous. It still takes time. And at this point, you don't have a value. And for the compiler to know that a situation like that can occur, you need to use a question mark when you declare your variable. So same as you did before, but you put a question mark after the type, and you can say that it equals to nil. So right now there is no value. So server response is absent for now. This way, the compiler knows that there could be a case when this variable doesn't have a value at any point. And it will prevent you from just using it unsafely. So in Java, the same situation, it would be, the keyword would be null. And in Java, there is no compile time null safety. It means that you can just accidentally access this variable and like pass it to another method or do something with it, or even just print it. And since your app doesn't expect that this variable can be null, so that the value can be absent, the app will actually crash. So user will see just some standard dialog saying, yeah, this app, how would you say? Yeah, interrupted or something, which is not really nice user experience. Yeah, and let's see how we can work with these optional types. So in Swift, it's called optional. First, you can work with these variables which may not have a value using if-let and guard-let statements. They're kind of similar, but work in the opposite way. So you say if-let response equals server response. From the previous slide, you see that this server response variable may be null. Then when you put a nullable, optional variable here, the execution will go as follows. So if the response is actually not nil, so if it's actually there, like, I don't know, 200, for example, then this variable will have its value. And here in the curly brackets, you can actually work with that. Here it's not optional, it's just int. And you can do anything you want with that. And if here this variable is actually nil, then you just go further. This block will be skipped. So which is a safe behavior, so you don't do anything unexpected. Guard-let, kind of the opposite, as I mentioned. So if this variable is nil, then you just jump into this block and you don't go further. Usually the guard-let is used for the early return. For example, you have some function which processes some properties, and right in the beginning of this method, you would say, for example, this guard-let response server response to make sure that all the properties are in the valid state, exactly how you expect them, before you actually start processing. And if something is wrong here, you just say return and you don't do anything what can cause your app to crash. And if this, if this is true, so if this variable actually has a value, a valid value, then you will just jump over this block and continue further, and you can process it. So both ways are helpful to work with optionals, but the use case can be a bit different. Another way, just a second, I need some water. So another way to work with the optional types is to use nil coalescing operator to provide a fallback value, how it works. So you see here, you needed to make sure that the variable is not nil. But here you say, okay, process server response if it's not nil, but if it is, then process 404. So it's either or. The nil coalescing operator picks the first one if it's not nil, and otherwise it picks the second one. You can also kind of chain them, so to have more of them here, but it's not always the most readable thing to do, I would say. But another option is to use force and wrapping. So here what you say is that I'm pretty confident that it's not nil. So much confident that I'm fine with the app crashing if it is nil. So it is really not recommended to do, better not to do that at all. Maybe in tests, but you shouldn't do it in your production code. Yeah. And another way to work with the optional variables is to use optional chaining. Really convenient thing. I will show you an example in the playgrounds too. But basically how it works. So we have a struct car, and here we define a variable of this type and tell that it actually may be nil. So we say that it is optional with the question mark. And later on, if we want to access any properties of this struct or any methods or whatever, we can just say question mark dot, and then either access property of it or call method or anything. So here in this case, we say we define a variable engine, and we say that it's engine of this car if it's not nil, but it will be nil if the car is not there. So basically the result of the optional chaining is always optional, because there is always kind of uncertainty. It's either nil or not. And yeah, so anytime you use optional chaining, it can be multiple, by the way, yeah. It will be always optional as a result. You will need to always unwrap that using if-let, card-let, or nil coalescing operator, anything. Yeah. So for example, here you could say if-let car equals car question mark dot engine. Sorry, here you would say if-let engine equals car question mark dot engine, and then if the car is not nil, then in this variable you would have the engine value. Yeah, and yeah, when you can also have multiple chaining, you can also call methods. So yeah, that works this way, really convenient. I would also advise not to chain them too long, because it really doesn't improve the readability. If you need to do something like that, maybe introduce a few variables just to keep it nice to read. Because of course you're not only writing code for the computer or for the compiler or for yourself. You're also writing the code for other developers to read. And also don't really count too much on yourself being able to read your code in half a year. Probably even earlier, you will forget what you were doing there and it will be hard. So keep your code as readable as possible. Yeah, now I can show it. Yeah, let's use the car example. It was fun.
Maybe quickly to throw this in here. Optionals is a pretty important concept. So if you feel like you have any questions regarding this, please raise that right away, because this is quite important.
Yeah, just if I'm going too fast, please let me know. I can repeat it or try to explain it in a different way. As Ralph mentioned, it is important, and we are totally fine with taking more time for that because, yeah, all good. Just let us know. Yeah, let's say there was engine, right? There was.
I have one question.
Mm-hmm.
Are there any performance drawbacks to optional chaining when it comes to performance? Because most compiled languages don't have optional chaining, but things like like JavaScript have optional chaining because they have a runtime most of the time.
So, Ralph, you want to answer?
I'm not aware of any runtime drawbacks. Could you maybe quickly switch to the slides, Irina?
Yeah, sure.
And go back, I think, to like one more. So what I know is that excessive nil coalescing operator usage, for example, has quite the impact on compile time. So that definitely is a drawback. So if you chain like server response question mark, another optional type, question mark, another optional type. So if you do that, this has an impact on compile time, but I'm not aware of any drawbacks regarding runtime, especially regarding optional chaining.
Thanks.
Sure. I hope this was I hope this answers your question.
So, yeah, then let's go back to the demo. Yeah, let's also have cruise control. How does it maintain speed? And we do something here. Maintaining. And the car has engine. Always has it, so it cannot be optional. And we can make the cruise control optional in this case. Yeah. For example, if you want to use, let's put it in another function. I know some process function. And you receive as a parameter to this function, you receive an optional car variable. As I mentioned, guard-let is a really nice way to early validate your input. Let's do it exactly this way. We say guard, you see condition. You can also put a bool value here. For example, you say, I mean, theoretically, you could say guard car not equal nil. Otherwise, return from this function. It is a not really nice way to do that because here your car variable will still be optional and you need to do something again. That's why guard-let is exactly for this case. Once you actually jump over this block, so you're already sure that the car is not nil, here you can do anything you want with it. So as you see, at this point we know that car is not nil, but the cruise control variable is still optional. So we still need to use the optional chaining. What we also could have done instead like this. So we used optional chaining in the guard-let, So if we don't actually care about the car, but about some property of it, we can just define a variable for the cruise control. Here we cannot use car because it is optional still, but we can say cruise control maintains speed without optional chaining, because if we are already here, it is not nil. If it is nil, then we will jump here and return the function. Yeah. Let's go back a few steps. No, not this many. Let's also try to use if let. Cruise control. So car is not optional anymore. It's a cruise control. So if let cruise control, if it is not nil, we can do something with it here. No, it prints already there. Let's just call it. So as you see, no question mark here because we checked it this way. And if it is nil, then we just jump over this block and end up here. You can also have S if you want to somehow handle the case, otherwise not mandatory though. Nil coalescing operator. Let's say, let's remove this. Yeah. For example, we can do another car, and we say either the car which we received or some new car. This engine, and let's say no cruise control. So this way we tell the compiler that this variable is going to have the value of the parameter which we received in this function, or if it is nil, then we say, okay, let's use another instance of this struct. Yeah, like this. Normally often you don't use this approach because in this way you cannot really see from anywhere outside that something went wrong and your variable for some reason has an invalid value. It's better to rather use, for example, guardlet and then handle it in some way. For example, use some logging or tracking or whatever to just find out somehow that your app is doing something what you didn't expect it to do. But this way you will never find out because you won't be able to see which value was used and that at some point the value was invalid. Of course, if you are fine with either, then it's a totally valid use case. Yeah.
Maybe crash the playground for some wrapping.
Let's do it. So let's say car, cruise control, maintain speed, and somewhere here we invoke this function. As you see, it doesn't really see that I have this function, but it should be fine now.
We'll see. No, you need to define. True. Sorry, it did.
The process has been left at the point where it was interrupted.
Yeah, you can see in the logger down below.
Yeah.
It actually.
Fatal error, unexpectedly found nil while unwrapping an optional. Yeah, so never do that really. First, because for a user it would be really not a nice user experience, and for you it's also not a super readable thing, I would say, because
yeah, you don't want to see such messages in your error logging or crash logging if you push an app into production. It's not the best. And it's easily preventable by using those tools Irina showed you now. So yeah, be sure to use your if and guardlet.
Yeah, so that's the reason why Swift is much safer than, let's say, Java, because in Java you always need to keep it in mind that some variable may not have a value, and you need to check it all the time. And yeah, often you just can make a mistake. Null pointer exception is a really common thing in Java projects. So yeah.
I have a question. What does nil stand for? Is it something like not initialized?
Tell me, Rod.
That's a good question. I've never thought about that. But in the end, nil is just a different word for null in Java. Yeah. Like it's basically the same thing, but if this is an acronym, I can't really say. Let me Google that. I don't know. It's a good question.
It comes from functional programming languages. There they use nil instead of null most of the time.
Yeah, that's what I wanted to mention. There are many languages which still use nil, and some of them use null.
Yeah.
Okay, thank you.
Swift has actually so Swift and Objective-C, mentioning Objective-C here like on purpose, has a bit of a complicated relationship with nil, null, and another null, so NS null. There's a bit of that goes a bit into much detail here already. So just as a warning, if you ever work with Swift and you interopt with Objective-C classes, because that's rather easily doable, be aware that null is not, so NS null is not the same as null, and null is not the same as nil. So at least not in all cases, it's confusing. We can talk about that when we a bit further down the road. Actually, I guess makes more sense.
I also have a question. What's the exactly difference between if and guard? I don't really get it.
Yeah, I will explain it again. So they're kind of the opposite. If this variable is nil, then you will jump over and end up here below. You won't end up in this block. And in the guardlet, it's the opposite. If it is nil, then you're ending up here inside the block and don't go further. So the behavior kind of the opposite.
Irina, maybe you can run it in the playground again. Like it might be a bit easier to understand if it's like in code directly.
So it means if you do not want to jump in, then you use the if, and if you want to jump in, if it's a nil, you use guard.
Yes.
Okay.
Yeah. So the use case for guardlet, normally, I would say, I don't know, 99% of cases, let's say it like that, it's beginning of the function like we did here. So if you don't have all the properties in the state which you need, you just return from this method and you don't go further. So that's the use case for guardlet. Anywhere else, it's if-let. So you say, if it is not nil, then do something what I specify in these curly brackets. But but it's something what you also need to use a few times just to get used to it.
Yeah.
Does anybody else have questions? I guess we can.
I'm afraid to ask.
No worries. There are
because you talked so long about that question mark, and I still don't really get it. The question mark is just there so you can prevent the nil, or I mean, not prevent, but you kind of catch it.
Yeah, kind of work around safely. So,
Okay.
so you work with the optional variables, which theoretically may not have a value, but you work with them in a safe way. So there is no way you can actually crash your app.
Okay, so if there is a possibility that your variable will be not nil, then you probably will use the question mark.
Yes.
Okay.
So
okay.
yeah. So when you define the type of your variable and say use question mark, you already let your compiler know that it may be nil at some point. Maybe not immediately like here, but somewhere down the road it can have nil value. And this way, compiler knows that it's optional, and it will force you every time you use this variable to make sure that it's not nil before accessing something. When I was mentioning optional chaining, I didn't go further actually. So in this case, when you just want to invoke a method, so if the car is nil, the method won't be invoked at all. So this is a safe behavior.
Okay, but if the car is not nil, but the cruise control is nil, the maintain speed also will not be.
Exactly.
Okay, okay.
Yeah,
All right,
so so on each step you're making sure that, because here we have car, which is optional, and cruise control is also optional. So on each step you're making sure that car is not nil, cruise control is not nil, and then you invoke the method. For example, if cruise control wasn't optional here, then we wouldn't need to use this question mark, because we wouldn't need to make it safe here, because we already checked that the car itself is not nil, and here we wouldn't need it.
Okay.
I think it's also, you can describe it as being more readable than doing if a lot of checking before you can use the method, something like that.
Yeah, I get what you mean.
Yeah.
If you don't really, I don't want to say if you don't really care, but if you're fine with the method not being invoked, if the instance is not available, then this is a one-liner compared to some unwrapping safely, of course, and then calling the method. So it just is a bit easier to write with the optional chaining. And maybe to explain a bit more why optionals, like how to phrase this. Imagine you request some data from your backend, and this is a rather difficult operation. No, not difficult, but it can fail. Let's say it like that. So you're not sure if you will ever receive a response, if the response is what you would expect, or if you get all properties that your class or that the thing that you want to actually, if you get all the information you want. So for example, in your network model, in your class or struct, whatever you have then there, you have a few optional values, because you cannot say that those will be there. And then you mark them with the question mark. And in further access of those properties, the compiler will enforce you to use safe access. Does it make sense?
I think. It makes sense, but I'll just have like to use it to get used to it.
Yeah, it helps trying it out. Yeah. I'm thinking how we could explain it more.
No, I think I got like the gesture of it, so it's okay.
Yeah. So if you in this current state, if you got why it's needed and what the use case is for it, then we're already pretty good.
Yeah, that's I got it.
Okay, cool. Yeah.
Yeah, and
thanks for the answer.
Yeah, and compiler will take care of everything else. It will force you to use the question marks. So should be fine.
And yeah, be careful. Xcode will sometimes recommend you to use the fuzz unwrapping. Don't do that. We'll get into that when we talk about Xcode. But yeah, thanks for the question.
Should we have another break, or?
It's again an hour. What's next?
Let's see. Control flow.
I guess a quick break would make sense. Should we do another 10 minutes? Is that fine?
Guys, how do you normally do breaks?
That's a good question.
Random.
Random.
It's random. But mostly, yeah, around 10 minutes and whatever the process.
I guess as this is pretty heavy theory, a bit more breaks would make sense. A lot of information to process.
It's no problem for me.
How do the others feel?
I mean, I have nothing against a quick break.
Breaks sound good.
Yeah.
Yeah, I see that.
So let's meet then at 52 minutes.
All right.
See you.
See you in 10 minutes.
So everyone is back? I guess.
Let's continue.
You still can see my screen, right?
Yep.
Okay.
Yes.
Great. So now let's continue with the control flow. So what exactly is that? In general, by default, your code is being executed. Let's say your code in the method is being executed one by line from top to the bottom. But sometimes you don't want that, and you want to somehow change this execution flow in one way or another, depending depending on the circumstances. For example, you want to execute a few lines of code multiple times, or you want to have multiple branches of execution depending on specific conditions. And let's see how we can do that in Swift. First, loops. Loops repeat some action over and over until some condition is true, or a specific amount of times. For example, if you have a collection, more in detail later about that, probably not today, but in general, imagine you have a set of some data. For example, you have multiple users or multiple exercises or anything, and you want to do some operation over and over for each element of it. Let's say you want to print a name of each student in the group. So you wouldn't really write this line of code, let's say 15 times, because it doesn't make sense, because the action is really the same. And if you see, if you notice yourself that you are writing really repetitive, so you really repeat yourself in the code, it's a really good sign that maybe you can optimize it in some way, maybe just do a loop so that the operation is repeated instead of you repeating it manually. So how you can do that for a collection? You just use for keyword. Then you put a name for the specific element. So when this action, printing in this case, when this action is being repeated for each element of the collection, variable with this name, num, will contain value first 1, then 2, then 3, then 4. So this line of code will be executed 4 times. You don't need to type it 4 times, but you tell you tell Swift, you tell compiler that you want this line to be executed this amount of times, or for each element. Then you put in keyword. So you defined the variable name. Then you say in, and in which collection. So in Swift standard library, all the collections, you can iterate over all the collections this way. Somebody wanted to ask questions?
No, just wanted to add this because I think you started with Java, didn't you?
What do you mean?
No, in the class. Sorry.
Yes, it's with Java. But
Yes.
Does it also start with 0 here or 1?
Index
0.
is 0. Yeah.
Okay.
Yeah.
But just to add this here, so this usual Java, I mean, there are for in loops in Java as well, obviously, but the classic for I equals 0, I smaller than some collection count, I plus, this doesn't exist in Swift anymore since a few versions.
Yeah.
So you need to opt for in loop.
Yeah, in general, in the majority of situations, you don't really need index because it is rather unsafe. Because human error happens all the time. You may be somehow wrong with indexing, and then you're ending up outside, and your app crashes. Although also important difference, Swift is safe So you will your app will crash, but you won't really access like the memory outside of the bounds of your array like you would do in C. So
Index out of bounds.
yeah, yeah. So although it is unsafe to use indexes, but it is unsafe because it is unsafe for you because your app will crash, but it is not unsafe in C way that you can access some data which you shouldn't.
Yeah, so like, Marco, did you want to ask a question?
Just wanted to ask this num, I mean, is our variable, but with what is it initialized? Like
the first element.
Okay, so
yeah. So in this case, it will be 1. But let's say if the collection is empty, then it will be nothing. You won't end up in this block any single time. So basically, it won't have any value, and you will just jump over. But if there is at least one element, it will be initialized with the first element, and this block of code will be executed for it with the 1 value, then 2, 3, and 4.
Okay.
Mm-hmm. Yeah, so now we'll continue with the while loops. Let's say in case when you don't have a collection to iterate over and to do something, but you want to repeat your action while some condition is true. So let's say while, I don't know, while the app is active, you want to refresh the frame and stuff like that. So something repetitive, something that repeats itself until some condition is true. You can do that either while using while, then you have some bool expression here. Let's say while something equals state active, something like that. And then all the actions which you put inside this block will be repeated over and over and over. And this condition will be checked again and again. And while it's true, it will be repeated. And then if it's false, it will stop and then continue further from below where you closed the curly brackets. Sorry. Same thing with the repeat while. So everything what you put in the curly braces after repeat keyword will be repeated as long as the condition is true. But be careful, because in this case, with the first while loop, it won't be executed any single time if the condition is initially false. But in the case with the repeat while, it will be executed at least once until it gets checked for the first time. So as I mentioned, your code is executed always from top to the bottom, and it just makes sense that first this statement is executed once, and then the condition is checked for the first time, and if it's false here, you will just end up somewhere below further. So this thing will be executed at least once. This is the difference. I would say while is way more common than repeat while. But depends on the use case. Yeah, so this section was about the repeating some action. This would be about branching your execution flows. First, it's if-else. So like in many other programming languages, you can branch in a few flows if some condition is true or false. So let's say if temperature in Fahrenheit, I pronounced right, less or equals to 32, then we do this, what is again inside this curly brackets. If it is false, we end up in else and we print this thing. You can also kind of chain them, and you can have multiple if else. Not super readable, but technically possible. And I will quickly mention switch. It is a really powerful thing in Swift. There are really many things you can do with that, and we have a separate slide for that, and I will tell more about that. But I want to show you in Xcode these things just to show how they work. So let's say we still have car, and let's have multiple cars. Don't focus too much on the collection thingy. Just imagine that you have multiple cars, like in a garage or something. Car. So engine. Let's put new. And then you can say for. Then you need to name a variable for each car. So it's a bit just car in keyword. It's always necessary, and then you put the name of your collection and open the curly brackets. In this case, everything what is inside here, you can put as many lines as you want. It will be executed for each of these cars. Let's say car. Since it is not optional, we can just access it without optional chaining. But let's say for each car we want to invoke maintain speed, then we need to access cruise control. But since cruise control is optional, and we will put nil everywhere, but it's just for the sake of an experiment. Yeah, like this. Question mark, maintain speed. So let's see what happens. So as you see, it printed maintaining. Here we defined a function maintain speed, which just prints. It was printed just once because in the first car we don't have any cruise control. In the second one we do. So that's why this function was invoked once, although the block was executed 2 times.
Yeah. That's pretty useful in playgrounds because you can also see on the right side that the loop was run 2 times.
Yeah.
I have a question.
Yeah.
It kind of confuses me that the fact that there is no normal for, like, for example, when you have a sorting algorithm and you want to split a list in half, how would you do that without a for loop?
I mean, there are kind of multiple ways how you can iterate over a collection. So further, when we actually start with the collections and closures, you would be also able to, for example, iterate over them like that for each. So you can do it like this, or if you want indices. I think it's enumerated.
Yeah, you would if you need an yeah, exactly like that.
Yeah.
So
this way. Sorry, go ahead.
Yeah, you can also add this to, like, if you say for car in cars dot enumerated. This is already a bit like would be a bit later in the slide set, but with enumerated you would then get a tuple, which Irina already talked about, containing the current index of the car and the car. So then you have the index as well.
Okay, so like a key value pair, kind of.
Yeah, exactly. Well, not exactly. It's a tuple,
okay.
But it kind of is a key value pair because you get the index and the car corresponding to the position in their collection. So.
But the order is wrong.
Yeah, exactly.
So first index, then car.
I always get that wrong as well. The order every time.
Yeah. Also, you can take a look yourself, and we also will look together. Collections have really many methods which are convenient for operating them. Let's say there's really a lot of stuff you can take. Wait, shouldn't there be take? How you take the first few of them?
Pop, I think.
Like if I want first 5 elements.
I think it's, or drop first. Sorry, not
Drop
pop, but
first.
drop first. Yeah.
Yeah, so you will get a slice, so just a part of your collection, if you want to do something like that. So really, there are a lot of convenience methods which help you to do some boilerplate stuff which you don't need to implement yourself.
But let's say I use the drop function you just mentioned,
yeah.
and I use an index that is out of bounds. What would happen?
I think it's not an index, but the amount of them.
Yeah, okay. Let's say I use an amount that is bigger than the size of the list.
Let's see. So.
But there are some of those.
Yeah, it
Sorry,
would be just empty. Yeah, or some of them if it can.
Yeah, so let's say you have an array with 3 objects in them. You request 5, you would get 3 in this case.
Yeah. So yeah, also important thing in Xcode, you can always press command and then a type or a method, anything you can just go in there to see how exactly it works. All the documentation from Apple is really convenient because first for collections there is an important, let's say, criteria is the complexity of some operation which you perform on it, and here for each method they mention the complexity so that you are aware of what you're doing, and that if your collection is too huge that you are not doing some I don't know, O and squared or something like that. But yeah, I would always recommend to read documentation. That's the most reliable source of truth. Yeah, and another case we were talking about while loops. I already did it once and crashed the playground, so I'm not doing it the infinite loop. Let's say what it could do. Let's say we just have some full value. It's running or something. This, and while it's running, I think I also don't need to put round brackets. Yeah, just got used to from Kotlin and Java. So while it's running, everything what you put in here will be repeated over and over. Yeah, while your app is active. Obviously, if your program shuts down, yeah, this will stop. Well, let's say print. Just running, and how do you do the delayed version? Let's say dispatch. I need to import it.
I think you need to import Foundation for that too.
Yeah. I guess it should work in the playground too. Dispatch queue. Also, don't focus too much on it right now. It's just, yeah, we'll look into it later.
.main.async, I think.
Sync. Yeah, but I want to sync with delayed.
Yes. Async after.
Yeah. So let's say,
I think it's dot now and then plus 0.5 or something.
yeah, exactly. Yeah. Plus 1 or something. And then what we execute is running false. Let's see if it works.
Yeah, no, it doesn't. Seems
Yeah,
like
it's
dispatch
still
queues are
continuing.
not the best thing in playgrounds.
Yeah, I'm not sure if it's.
But shouldn't it like never get to dispatch queue? Because while running, it will just.
Yeah, you're right. It will never get there because the queue is busy with updating it. You need to move it before.
Yeah.
You're right.
Yeah, you're right.
Is it still running?
Mm-hmm.
Maybe you need to quit the application again and reopen it. Yeah, no, you can trigger it again. Or not.
No, I can.
Interesting.
Okay.
It's confused.
Yeah, me too.
Yeah, usually you would use a while loop with some state that you at some point mutate while iterating.
Yeah.
And then you have just an exit.
Yeah, so usually they don't go just one by one, but rather like separate things happening. Yeah. Yeah, I'm not a regular user of playgrounds.
Yeah. Yeah, try to kill exclude.
I'll just force quit it. I think it was this. Probably not. But yeah, so I showed you while loops and for in loop. If else we kind of discussed already in the context of optionals. So yeah, it's not it works not only for optionals if let variable something, it also works just for the bool expressions. So yeah, if this one is true, it will print its very code, consider very scarf. Let's see how my Xcode is doing. It's here. Second. We'll create a new playground.
What might be interesting regarding if let, if else, and so on, you can combine those. So you can say if let server response equals server response or whatever optional you have, and then you can do an and or an or actually even just a comma and add additional conditions.
Yeah. So for example,
also pretty extendable.
Let's say we have some variable number which can be can have nil value, and then later on in some function you would say if let number equals number and some bool expression like which is, let's say, true. And then in a comma separated list, kind of, you can also put a full expression. So this way, this part will be executed only if the number is not nil and if is true. So if this is false, it won't be executed even if the number is not nil. Both of them need to be true. It's how to say that, equal to
And
yeah.
Exactly.
Yeah. And I guess we can start with switch. As I mentioned, it is rather powerful. There are many ways you can split the flow. And let's see on the next slide. The approach is called pattern matching. So you can compose some complicated pattern to which your variable needs to match to fit. First, it can be interval matching. Let's say you have some number, and depending on which range it falls, you may want to do different things. Here you say, so you need to use switch keyword first. Then you put the variable depending on which you want to actually split the execution. And then you say case, you put the range. So in this case, you say if the remaining time in seconds is in the range of 0 and less than 10, then print this. Then if it is between 10 and 60, do this. And if it's between 60 and including 300, you print this. And there could be also a default option if none of these conditions are true. If the variable doesn't fit to any of these conditions, you will end up here in the default option. Yeah. Then it can be a tuple matching, which I already told you about tuples. So here's again a point declaration. And then you can have multiple conditions for both of the, oh, not both, but all of the components of your tuple. So in this case, in the first example, you say, if the first element of the tuple is 0 and the second one is 0, then print this. So since we have 0, 1, it won't match to this pattern. In the next case, you say, I actually don't have any requirement for the first component, but I care that the second one is 0. And then this line will be executed. In this case, again, it won't happen because the second component is 1. Then you go further and you say if the first component is 0 and there are no requirements for the second one, we print this. And in this case, it will be true. Just a second. Yeah. There could be more complicated patterns like ranges again. In this case, you say if both elements fall into -2 until 2 ranges, then you're printing this thing. And if none of them are true, you will print the default option. Yeah. I will be right now. I'm just shortly telling about all the possibilities, and then later we will switch again to Playground to try it out. Because, as I said, there are really a lot of things you can do with switch. Another thing is value binding. So as you see here, when you ended up in a few of these options, you were trying to access a property of this tuple. So you say, I don't care what value it has. I just want the second one to be 0, and then you print the first element. In this case, it can be even easier, like nicer, shorter. You can bind it to a variable, this value. So this is essentially equal to this line, but in this case, you also don't have any requirement for x, but you are binding the value of x to this variable, let x. And inside this case, if it is true, you can then use it as x instead of just saying another point dot x. You can have also multiple variables, like here. Yeah, really convenient. And you can also use where clause, so to make it to make your pattern even more complex for some really specific conditions. The same thing again. Here you are binding the values to these variables, but you also can use where to check if some bool expression is true. So in this case, you want to bind the value of x and y to these variables, and you want to execute that only in the case when x and y are the same. In this case, it won't work because they're not. Then you go to the second case. You again want to have the values of them, and you say if they have the opposite values, then you want to execute it, which is true, and you end up here printing this thing. Of course, it can be even more complicated than that, but yeah, that's the functionality. And I guess let's switch to the playground to try it out. Let's say, yeah, let's do it with tuples. So as you see again, you don't necessarily need to name them when you define an tuple instance. So you can say x and y, but yeah, not really necessary. Let's do it in some function. And then you say switch. So first you need to put the value. We put point, because depending on the point, when we want to do different things. Let's say the first case would be, again, we want to, for example, check if x and y are the same. In this case, we would say let x, let y, where x equals y. So in this case, you need to bind them to the variables because you want to use these variables here. Otherwise, you can just ignore them. But in this case, you won't be able to use them this way, and you will need to say point x, point y, which is fine too, but yeah, I guess depends on your preference. Yeah, and yeah, here you can do anything with these variables. Also, since some of you are familiar with other programming languages, in some of them, the cases are kind of falling through. So if multiple of them are true, you kind of can end up in a few of them if you don't put break. You don't need to do it in Swift, so it doesn't fall through. So
but you can fall through if you want to, but
yeah.
Never needed that, to be honest.
So it will always break when the first case is
Yeah.
equal. Okay.
Exactly.
You can... Go ahead.
Sorry, I'm interrupting you. Yeah, so just wanted to say, yeah, exactly. So if when it hits the first case that it evaluates as true, it will then execute the statement that's inside there and then break. If you state fall through underneath, then it will have this usual behavior of not of falling through.
Okay.
So I think it should also work like this. Wait. If I have multiple cases. Of course, I don't have it here. No, it doesn't like it. Not everything. Yeah. What else you can do? Yeah, as I mentioned, ranges. You can do example. Let's say and again just something. Yeah. So in this case, it won't also work because we use the less than range. So since y has a value of 3, this it won't fall into this range because it is up until 3. And if nothing works, actually this one will work, but otherwise if nothing works, you end up here. I didn't invoke the function. Yeah, so yeah, not solve this, but yeah, it's printed this thing. And let's say if we do, we put some other this like this, we should end up here. No, it's still 3. Sorry. Let's use the including one. Yeah. In this case, we end up here. Yeah, so as I said, really powerful feature because you can do so much and without too much code. It's really nice. Of course, if it's getting the case is getting more complicated, maybe some additional variables or at least some comments saying what exactly you're doing. It would be also nice. Yeah, in Swift. So if you want to put one line comment, you just use 2 slashes. If you want to put multiple lines, yeah, you do it like this. And I think this one would be for the documentation stuff. If you want to put something for the method or for the class, it's a common thing and good thing to do to explain what this function does, what this function returns, what parameters it receives. Yeah, like this. For example, when you look in the Swift documentation, let's see it. To exhibit. Yeah, you can also use 3 slashes for that. Let's go somewhere in the beginning. Yeah, so as you see, Swift provides a really extensive documentation to what they're doing often. Yeah, and as you see, the Mhm. Xcode formatting also helps the readability, so the code is highlighted and the text looks different, so easier to read.
You can directly access the documentation by option clicking on some call. So I don't know if you say int.max or whatever. This would then you can just option click on it, and then Apple's documentation or your own documentation will pop up.
You mean?
Yeah.
Like this. Like
yeah,
this.
exactly. So option, or for Windows users, Alt. But on the Mac keyboard, it's the option key. Then you get direct access to the documentation. And if you provide your own documentation in the format that Apple makes you use, then it will look similar. So it will automatically format code, and like you can see in this example.
The parameters, the code examples, and if there are any return types or anything like this.
Yeah.
Really convenient. Yeah, but I guess we're going to have another introduction in Xcode in more detail.
Yeah. Exactly.
Functions. Do we still have time, by the way?
We have, I think, until 55, is it? I think.
Yeah.
Yeah. Okay. Yeah. I'm not sure. I guess we can still start with it, but we won't get it done.
Yeah, and let's maybe leave a bit of time for questions, I guess.
Yeah. By the way, are there any questions for switches and pattern matching or anything other related to control flow?
I have a question, but it's not really related to control flow.
Yeah,
that's fine.
It's just, will there be an exercise until next?
Not until Friday. Not until Friday.
Okay.
I wanted to mention that, like, when we're done.
Okay, sorry.
No worries, no worries. It's a valid question.
Yeah, just to show you, this slide deck is pretty, rather big. So until then, first we're doing the whole slide deck, so you get more familiar with Swift. Also trying around, playing around with it a bit, and after that you will have an exercise.
So what I had planned for next week was doing a quick recap of what we did today, and then you have a bit of time to play around with the playground, to just try out stuff like we said before. Optionals might get clearer when you use them. So, and then we can continue. But yeah.
I have also a question about the is equal sign. At the beginning, you did you compare with 3 equal signs.
Yeah.
And that's equal to the addresses, right? To the memory addresses, or what is that?
I mean, yeah, the references. Not exactly. You don't really work with memory addresses in Swift, but rather you're comparing that these variables reference the same instance.
Okay, and with 2, you compare the values, like, or what? What do you compare with 2 equal signs?
For custom types, there is the equatable protocol. We will get to that a bit later. So let's stick to primitive types. With primitive types, string, integer, double, float, whatever you name, 2 equal signs just state if they have, like, integer A is 17, integer B is 16. 2 equal signs will equate to false. That's like the obvious thing. So yeah, you're right. It compares, like, on an, I don't know how to phrase it. Like, it compares the value and not the reference where it points to.
Mm-hmm.
And for custom types, like our car example, you will need to implement a protocol. We will get to protocols a bit later. And there you define what makes this equatable. and then you can use I lost the word.
Equal signs.
Equal signs, yes, thank you. Yeah. So, but you're right, it compares then the value, and for your custom types, you need to define it. But just to throw that out front already, Swift is very smart by now, so most of the time it will be able to synthesize such conformances, and then you don't need to do anything other than adding the conformance. But we will get to that a bit later.
Yeah. Also, another thing, normally you don't need to really check whether variables point to the same, if the references are the same. I just used the 3 equal sign just to show you that they actually share the reference, that they point to the same instance. But normally you don't do that. Normally you care only if the variables have the same value. So in this case, you would use just 2 equals sign. And for your custom types, as Ralph mentioned, you would need to implement it. Let's say if you have custom type user, you would want to say that another user equals to this user in case if they have the same name and the same last name or something. So you define in which case they equal.
Okay, got it. Thank you.
Okay. Any more questions? Doesn't look like it. I don't know. Should we still start this slide? I guess this is a rather.
Yeah, just really quick, because I already used functions in the examples. Just yeah, let's start a bit. So you probably noticed that sometimes I say function and sometimes method. There is a difference in meaning. So if you have just a function which is not bound to any type, you can just say function. But if this function is inside another type, let's say like we had for the cruise control, we had maintain speed, that would be method. Technically still function, but also a method because it belongs to a type. Yeah. Essentially, functions are really important concept in pretty much any programming language, because first they let you reuse the code, because you don't need to type the same functionality multiple times, so you can reuse it. Second, it also makes it more readable. So try to avoid making really big functions, because then it's really hard to grasp what's going on. And when you have smaller ones, and if you give them really descriptive names, then it gets really easy to read it. And yeah, you pretty much then don't need too many comments to that, because it will be clear what is going on. Let's say in this case, I don't really need to tell that this function calculates area of the circle, because if you name it in a descriptive way, it is really explaining itself what it's doing. It calculates area of the circle. Yeah. So let's see how exactly the functions are declared in Swift. First, you always need to put func keyword. Then you put the function name. Then when you open the round brackets, you put the parameters. A function may or may not have parameters. Also, you can define external name for your parameters, how exactly it will work. So you see here, we use this function, let area calculate area, and compiler will force you to use the external name of it. And if you pick them properly, then it will just read like a sentence. You say that let area equals calculate area of circle. So let's say if you didn't put this external name, if you just omit it and just say circle, then the parameter name will also play a role of external name, and then you would need to say calculate area circle. Yeah. Then you can put a return type. So your function may return something or may not. Same as you would say in Java, it would be void. So, but if it is void, you don't need to put anything. But if your function returns, you need to declare it always. That in this case, it returns double. Yeah, you use return keyword when you want to complete the execution of your function. Function can have multiple returns. If you have, let's say, multiple branches, for example, you have, as we already saw, the guard-let statement, we may return early. Yeah. What else? Yeah, the external names. And also, yeah, if you want to avoid using the external name, you can just put the underscore. In this case, when you call this function, you just put the parameter without really naming it, without putting the name of it, like here. It would be without parameter. Depending on the use case, all of the options are pretty valid. Then, yeah, I guess that's it here. Yeah, the parameters of your functions can have default value. So those of you who know Java, they know about methods overloading. So when you name them the same way, and you just have different parameters, and depending on the case, you use different function, different method. But in Swift, you don't really need to overload them. You can just provide the default values. Although you can also define another function with the same name if it is necessary. So you can kind of have both. But in this case, your function has 3 parameters, and we define default values for 2 of them. So to put a default value, you define a parameter, then you say equals, and then this value will be used if you don't provide anything else. So in this case, this function can be invoked in these many ways. So a name will be always mandatory, as you see, because we don't have any default value. And then you can either provide a second one or third one, or both of them, or neither of them. Yeah. Are there any questions? I can be sometimes a bit fast, so let me know, please.
I have a question. Is the order how I put the parameters? Is it can I for example put path at first parameter and then name?
I don't think it works in Swift. I know that you can do that in Kotlin though.
I think it should work. It doesn't really like. Did I get it right that you mean like the same function with the default parameters, but just switch path and name?
Yeah, I think so.
Yeah.
Yeah, that should still work.
The thing is, you probably won't do it often, because when you start typing your function to invoke it, the compiler will already offer you some auto-completion, and then you will just use the standard order pretty much always.
Okay.
Yeah.
Thank you.
Any other questions? Let's see how we're doing with the time.
Yeah, it's less than 10 minutes.
Yeah, let's not go further. I guess it's probably too much.
I guess it's fine, yeah. Are there any general questions for, I don't know, anything relating to the course, I guess.
I have a question about, you said in the beginning that Xcode was okay for small projects, but what is used for bigger projects, AppCode or?
We still, so I can only speak for Runtastic now, to be honest. We have rather big projects. We use Xcode because, like I said, sorry, most of the time it's like a very good development environment. But as the project grows, it just sometimes takes slower, gets slower. I'm not sure if AppCode would be that better in terms of compilation time, for example, but I haven't used it in quite some time, but there might be some benefits in terms of syntax highlighting. Sorry, what was that?
Performance.
Performance, yeah. It's, not sure how to phrase this now. Yeah, it has its drawbacks, let's say it like that. But for examples, if you work with storyboards, you don't get around using Xcode because AppCode doesn't support them, if my knowledge is still up to date. Yeah. And Xcode is free, which is also a pretty big benefit in my opinion, other than you need a MacBook to, or a macOS machine to actually run it.
But yeah, if we're talking about big projects, I would say pretty much any IDE has these drawbacks.
Yeah.
I was working with Android Studio for 4 or 5 years, and yeah, it happens pretty much anywhere because it's just physically takes more time to process more files.
So overall, in like very general terms, Xcode is very great, but obviously, as Irina said, everything has its drawbacks at some point.
Okay, so this the environment IDE takes a lot more time to process the files, but in the beginning, but when you're developing, it's okay, or does it get slower? Because
sorry, go ahead.
Because from what I understand, it's the compilation time that gets slower, and that's normal.
Yeah, it is. What causes pain, if you want to call it that way, or makes it slower is that, for example, if you switch branches to a different task that you're working on, Xcode tries to index the files again. So this slows down the whole process. But yeah, as you said, compile time increases with more files, and more files come from longer development time on a project. So that's pretty natural. You're right.
Yeah, and I wouldn't say that it is this bad, especially since it really takes a lot of time, a lot of people, and a lot of effort to end up in a project which really takes extremely long to compile. It is not that, yeah.
Like just an example, we're working on the, for example, training app for more than 5 years now, so it's obvious that the size grows and it takes longer.
But yeah, also we need to, and we are trying to take care of all the old code, because often we implement a new feature and stop using some old functionality. And sometimes if somebody forgets to remove it, it just ends up as a dead code, which is not really invoked, but still takes time to. So now we are trying to pay attention to that too. If you, in general, keep your code base in a health state, it also improves the situation.
Okay. Yeah, we're nearly done for today. So we'll meet again on Friday, I think at 1. We'll continue then alone with me, because this was just like this modus that Irina and me both do the lectures only like for this lecture now and for the last. For the next few lectures, we will like switch them every time. Yeah, so on Friday it's with me. We will just continue here then, and yeah, I guess there's not that much to add. We can go over any unclear things again. If you have any questions, feel free to ask them then on Friday, so we have enough time to talk about them. I don't want to steal any more of the evening. And if there's nothing more that you want to ask now, I guess we can call it a day.
Yep.
And it doesn't
Sounds
seem
like
that way. So have a nice evening, and I'll see you on Friday.
Yeah, and I will see you next week.
Thanks, you too.
You too. Thanks.
Thank you.
Thanks.
Bye.
Bye-bye.
Thanks. Bye.
Bye.
You too.
Bye.
See you next time.
See you.
Bye.